Welcome to today's Explainer, where we're going to demystify one of the absolutely coolest components you can add to your electronics toolkit, the flame sensor. If you're a beginner looking for a dead simple step-by-step guide to building a fire detection setup with the Arduino UNO R4, well, you hit the nail on the head. You're in exactly the right place. We're going to take this whole thing from basic concepts all the way to a fully functional smart home project.
So here's our roadmap to get us there in just under 4 minutes. First up, Section 1 will meet the flame sensor. Then, Section 2, wiring your setup. Section 3, testing and tuning. And finally, Section 4, the Smart Fire Alarm Project. Let's get to it.
Starting off with Section 1, meet the flame sensor. We're covering the basics of infrared fire detection here.
So, at its core, you can think of a flame sensor as basically a robotic eye. But instead of seeing normal light like we do, it's specifically designed to see the invisible infrared light given off by a flame. And the really brilliant part, it's engineered to focus purely on specific wavelengths. That means it actively ignores everyday infrared sources, like your own body heat or the light bulbs in your room. It's looking for fire and only fire.
So the crucial point here is how this sensor actually talks to your Arduino. It kind of has two distinct voices, or output pins. First, there's the digital output, or DO pin, which gives you a simple yes or no. If it sees a fire, boom, it sends a low signal. No fire, it sends a high signal. It's really that black and white. On the flip side, we have the analog output, or AO pin. This one tells you how big or how close the fire actually is. It measures intensity, so as the fire gets bigger, the analog value goes up, and as it shrinks, the value goes down. Pretty neat, right?
Moving right along to Section 2, wiring your setup. This is all about getting that sensor connected to your Arduino.
And I promise, if you've never wired a breadboard before, you're going to do just fine. It really is a simple 1, 2, 3 action plan. First, you just give it power. Connect the sensor's VCC pin to either the 3.3 volt or 5 volt pin on your Arduino. Step 2, provide a ground path by linking the sensor's GND pin to the Arduino's GND pin. And finally, pick your signal wire. Just connect either that DO pin or the AO pin to an input pin on your Arduino UNO R4. And that's literally it. The hardware is hooked up.
All right, Section 3, testing and tuning. Time to write a little code and adjust our sensitivity.
Depending on how you wired it up just a second ago, you'll test it in one of two ways. If you connected that digital pin, you're going to use the digital read function in your Arduino code. When you open up your computer's serial monitor, you're going to see a super clean, simple text message, either "the fire is detected" or "the fire is not detected." Easy. Now, if you went with the analog pin, you'll use the analog read function instead. This time you'll see a stream of numbers constantly changing based on exactly how close you hold a real flame to the sensor.
Now, what's really interesting here is dealing with false alarms. Notice that tiny little physical dial on your sensor board? That's called a potentiometer. If your digital test is kind of acting up, like maybe the warning LED is stuck on when there's absolutely no fire, or it just won't trigger when there is one, don't panic. You just grab a tiny screwdriver and twist this dial to adjust the sensitivity threshold. But keep this in mind, because it's super important. Twisting this dial only fixes the digital output threshold. It doesn't do a single thing to your analog output readings.
Okay, bringing it all home with Section 4, the Smart Fire Alarm Project. Let's put everything we've learned together. To upgrade our simple sensor setup into a fully functional, totally awesome smart alarm, we're going to bring a few extra components to the party.
Now that you have these incredible new maker skills, what other smart home safety devices are you going to build next with your Arduino? Seriously, the possibilities are endless. Keep tinkering, stay curious, and I'll catch you in the next explainer.